Hi everybody, my name is Kerrie Childress and I teach high school science classes for Excelsior Classes. And today's video has two purposes. The first one is to discuss chemical and physical reactions and to show you some of my favorite demonstrations that I show in my classes, both virtual and face-to-face. And it's using materials that most of the time people don't have at their home or at their disposal, but that I can order from a chemistry supply store. And so you can show these to your students and show them a couple of cool examples of chemical reactions. And then just to discuss at the end, I'd like to discuss with you how easy it is to do labs at home and to get things from just your local grocery store. And the main focus of labs, of course, is for analysis and observations and to really make budding scientists. So let's get started. The first thing is to discuss chemical reactions and physical reactions. And real quickly, just to remind you of the difference. So a chemical reaction is one that is going to change the product. So you put reactants in and you actually get something new. There is something new happening at the end. There's a new product. So some of the things that we're going to be looking for to tell us if we have a chemical reaction is we're going to look for color change. We might look for heat produced or light. And then there's also the idea of a precipitate or a solid that's formed, and usually it sinks to the bottom at some point in the experiment or maybe after you let it sit for a little bit. And then gas production is another one that students can look for. So what I want to do first is show you one of my favorite experiments. And I have two different products here. One is potassium iodide and the other is lead nitrate. And let me show you what happens. So first of all, this is how they start. They're just in bottles and you can see how very clear they are, almost like water. So I'm going to pour one into my beaker and I'll show you what it looks like in the beaker. Very simply. And this one is nice because there really is a reaction no matter how much you put in. So there's not a lot of measuring there, and I like that. So now I'm opening my other bottle and I'm going to show you exactly what it looks like when these two mix, and then you can show your students. So this is my lead nitrate already in there, and now I'm going to put in my potassium iodide. And you can see a very dramatic change that takes place. So I'll hold it up there and you can see that bright yellow color. So you can see a color change. And I'm going to let this one sit. And at the end of my video, before I close out, I will show it to you again. And you'll notice, hopefully it'll have enough time to sit, and you'll actually notice a precipitate. So a couple of different things going on there. Now, there is no gas produced in this one, and no light. So you do have some of the other ones, which is a really cool idea. So these are a couple chemicals that you would have to get from a chemistry supply store and not readily available at the local store. But I think that one's a really cool one as well. And my other favorite one is I actually like to use magnesium ribbon. And magnesium ribbon is, again, something I have to get from my supply store. But it's really cool. It's very brittle, so that's one of the things you can talk about as you're talking about those particular metals and how brittle this is. Let me show you the reaction that I get when I put this into a flame. Now, what I'm producing here, as you'll notice, okay, so let me show you what's going to happen. So here's my flame. And this takes just a second. It has to get hot enough. But what I'm producing here is an oxide. It's almost ready to start. I can see it happening on my end. There it goes. It's going to produce an oxide, which is a different material than what we started with. There it goes. Look away a little bit. It's very bright. And so that is a cool one to do as well. But that is not something that you can just buy at a local store. But you can see that one's very dramatic, and now I have little pieces flying around a little bit. So that one is forming an oxide from the oxygen combining with the magnesium. So you're getting a new material at the end of your experiment or your end of your reaction. So that's another key chemical reaction. So those are two of my favorites that, again, I like to demonstrate for students and online so that students can see that. But let's talk about physical reactions, as I have magnesium flying around my head. But a couple of different reactions that also I like to talk about are simple ones for physical reaction because you're just changing the state of matter. You're not actually forming something new. So for example, you can just take a piece of paper and you can rip it. And you can say, okay, this is a physical change because I still have paper. Now, paper, like paper towel or regular paper is a nice one to do, because you can then burn this and show the ashes. And again, that would be a chemical change. So you can show back and forth how something can be a physical change and then slightly altered into a chemical change as well. But definitely try out your stores and try kitchen chemistry. That's a great thing to search for, because you can use, I know I use baking soda and vinegar a lot, and that's a great chemical reaction, and you can do different ratios to see what happens. And students love that one because it's a big mess sometimes. So that's a great one to use. For biology or life science experiments, you can do mold. You can purposely or not purposely make mold in your kitchen. You can have it on bread or fruit, and you can inspect that. You can also do experiments over time to see how long something like that takes time to grow. So those are some great ones for life science. For something like ecology or studying different populations, I like to go out into my yard and you make a square with string or something, with stakes in the corners, and you just make a square and have students investigate that square and see what the population is of ants and bugs and different types of plants that live in that square. And so that's a great one for earth science, life science, ecology, studying populations. It can be even mathematical as well, looking at graphing and things like that. But just exploring. I think the biggest thing for us to get our students to do is to think, to analyze, to solve problems, and really just to explore the world around them. And so it doesn't take fancy equipment, but I was glad I could show you a couple of my favorite chemical reactions that you can maybe use to show this video to your students. But definitely just having them explore, having them investigate around them. Thank you for watching.